So welcome to the fifth week of this course. So we have, so in this week we are going, we will be moving up the hierarchy of solving this language processing tasks. Okay. So we had started with discussing about how do we handle individual words, how do we make use of the word order information using language models, and then how do we assign various grammatical categories or part of speech categories to the words. Okay, that's what we were doing till now. Now we will go to the next level where we will try to see can we arrange these words in certain groups. Okay, so this is what we study in this topic of syntax. So how are the words being arranged together? Okay, and what can we how we can automatically find out this arrangement given a new sentence. This will be the topic of parsing that we will discuss in this week. Okay. So what is syntax? So in general, syntax refers to the way the words are arranged together. Okay. And also we will see what is the relationship between various words and the word groups. That's what we talk about in syntax. So when we were talking about language models, we had discussed what is the importance of modeling word order. So which words occur after what other words, how we can make use of that in assigning probability for a sentence, or finding out the next word in completion tasks or spelling correction tasks. Okay. Similarly, when we were talking about part of speech tags, we saw what are the grammatical categories, part of speech categories. So this defines in one sort of equivalence class for words. That is, all these words behave like they are verbs, they behave in some equivalent manner. Okay. Similarly, all these words are nouns, they behave in some equivalent manner. Similarly, all these are adjectives. So we are defining some equivalence classes. Now in syntax, we will find out some more complex notion, like what is constituency, what are different grammatical relations among the words, what words are grouped together in constituency. Okay. And subcategorization, etc., are also included in this topic. Okay. And yeah, just to make you understand what is this notion of syntax, so you can relate to that if you see this particular meme. So I hope you remember this particular character from Star Trek. Yes, syntax, the only part of the language it is not, but important it is, right? So you can see the way words are arranged normally in the way we speak and how they are arranged in this particular sentence. Okay, that was a very special characteristic of this character. Okay. So now, so what are we going to study in syntax? So let me give you a simple example. So I have the sentence, the man read this book. Okay. So by syntax, we are trying to find out what are the various groups of word, okay, that are coming together. For example, in part of speech tags, we found out that the word the has a part of speech of determiner, man has a part of speech of noun, read has verb, and so on. Okay. Now we are going one level up. So now we are saying this is determiner, this is noun, which is kind of nominal, but they both together make a phrase, noun phrase. So I am saying the man is a noun phrase. Similarly, this book is also a noun phrase. So there are two noun phrases here, the man and this book. But when the verb read or any verb comes before a noun phrase, it makes a verb phrase. Okay. So all these three words act as a single unit of a verb phrase. Okay. There is no such unit for man and read, right? There is a unit for read this book and the man. And then I go up saying that a noun phrase and verb phrase are making the sentence. And this gives me a complete hierarchical structure of how the words are arranged in the sentence. The sentence is nothing but a noun phrase and a verb phrase. This noun phrase contains a determiner and noun, verb phrase contains a verb and a noun phrase which contains, and so on. So this is the complete hierarchy of the sentence that I come to know by this syntax tree. And that is what is the topic of this week. How do we come up with such syntax tree for some sentences? What is the particular formalism that we will use? Okay. So let me start by defining some basic notions, like what is constituency. So in the last example, we saw that a group of words, right, they are acting as some single unit. and you can call them as phrases, clauses, etc. So in part of speech, we could have done this substitution test. So I have this sentence, there is a fill in the blank, one in the room, okay, and I can fill in any adjective, the green one, the fat one, and intelligent one, sad one, all that can be filled in. So I can fill in any word that belongs to that particular part of speech category. Now here it will be a particular constituent, it will be a particular group of words that can behave similarly, okay, like here. So all these four things, Kermit the Frog, they, December 26th, the region he is running for president, all these are noun phrases, okay, and they can occur in a given context. So now for substitution test, you can substitute any of these four noun phrases. And yeah, we will see an example where all these can come in a very, very similar context. So how do we name these constituency phrases? So last slide I was showing some noun phrases. So why do we call them noun phrases or something else? So usually the names are given based on the words that are heading these constituents. What is the head? And loosely speaking, you can find the head by the word that can be substituted for the whole thing. Okay, let me take the first example. The man from Amherst. Okay, this is a phrase. There are four words. Now, which of the four words do you think can substitute the whole thing, or that can be used in the grammatical function of the complete unit? And that would be man, right? The man from Amherst. The word man can be used to denote the grammatical function of the whole unit. So the head here is a noun, man. So this will be called a noun phrase, okay, because the head man is a noun. Similarly, extremely clever, the head here is clever. This is an adjective, so this is called an adjective phrase. Down the river, here head is down, preposition, so this will be called an prepositional phrase. Killed the rabbit, the head here is the word killed, which is a verb, so this will be called a verb phrase. So like that we define what are the constituency phrases by taking what is the head of that phrase. Now, in general, words can also act as phrases. So a phrase need not have always multiple words. A single word can also be a phrase. So let's take the simple example. Joe grew potatoes. So now Joe itself is a noun phrase. Okay? Potatoes are also a noun phrase. They are nouns but also noun phrase in this case. Now compare this sentence with the man from Amherst grew beautiful russet potatoes. So what are you seeing? So instead of Joe, I have substituted the man from Amherst, a four-word unit. That is again a noun phrase. And beautiful russet potatoes instead of potatoes. They are still noun phrases. Okay? So what happened in this sentence? Joe is in a place where you could have probably put a larger noun phrase. Now this gives a very nice idea about the structure of the sentence. Okay? So in sentence I am having a noun phrase and a verb phrase. Verb phrase contains a verb and a noun phrase. And in noun phrase you can either put a single word like Joe, or you can put multiple words like the man from Amherst. Similarly, in that noun phrase you can put potatoes or a bigger noun phrase like beautiful russet potatoes. So this gives me a lot of idea about how words are grouped and arranged together. Now, so is there some evidence that constituency actually exists in language? So yes, so there are two different evidences. One is that these phrases appear in very, very similar environments. So now I'll talk about the four phrases noun phrases that we discussed in one of the earlier slides. Like, so you see these four examples. Kermit the Frog comes on stage. Okay, they come to Massachusetts every summer. December 26th comes after Christmas. The region he is running for president comes out only now. So all these four noun phrases are coming in a very similar context of the word say come. Yes, but I cannot take any individual word from here and put that in the context. So I cannot take the word the and say the comes out or I cannot say is comes out, or I cannot say for comes out in this sentence. Okay, I can only say the reason he is running for president comes out only now. Okay, not any individual word. So this whole thing behaves as a single unit, and they occur in similar context. All the noun phrases are occurring in similar context. This is one evidence that the constancy is actually there. What is the other evidence? So other evidence is that this whole phrase together can be placed in many different locations in the same sentence. Okay, so for example, if I take on December 26, that is a prepositional phrase, and I can put it in many different places in this sentence. On December 26, I would like to fly to Florida. I would like to fly on December 26 to Florida, or I would like to fly to Florida on December 26. All three are valid sentences, and where this complete phrase on December 26 has been put in multiple locations. But you cannot break this into two parts and put it in places. Okay, so you cannot say on December I would like to fly 26 to Florida, or on I would like to fly December 26 to Florida. You cannot say that. So this will act as a single group. It cannot be split apart. Okay, so these are some evidences that constancy actually exists in the language. Now, what is a formal tool by which we can model this constituency? That is, how words are arranged together, which words come together and which words do not come together. Okay, and what groups make a sentence, what groups make a verb phrase, what groups make a noun phrase. How can I model all that? What is the formalism? Okay, and if you have taken a course on formal language in automated theory or theory of computation, you might already know that the formalism that can be used is context-free grammar. Okay, this is the most common way of modeling constituency. So in one of the earlier lectures, we had talked about the regular languages by using deterministic finite automata or finite automata. Okay, so this is context for context-free languages by using the context-free grammar. Now, so I'll not go in very basics. I'll just talk briefly how do you use context-free grammar. I'll also define the notions. What is context-free grammar? So in the case of context-free grammar, what you will have some sort of prediction rules. That's what we are mostly interested in. So what do? The prediction rules will try to express what are the ways in which various symbols of the language are grouped together. Okay, and that is our main interest in using context-free grammar. Which symbols are being grouped together that I can use, that I can find out using, or I can express using the prediction rules in context-free grammars. So let us see one simple example. So I want to model this fact in language. That is, noun phrase can be composed of either a proper noun or a determiner followed by a nominal, where a nominal can be more than one nouns. That is something I want to express about language. So how do I use the context-free grammar? So I will say noun phrase is proper noun or determiner nominal. Okay, and nominal is noun or many nouns. So how do I write it in context-free grammar? I'll say noun phrase is proper noun or determiner nominal. And what is a nominal? It is one noun or more than one noun. So noun or noun followed by a nominal. Okay, so this is the recursion here. So I can allow as many numbers of noun as I want by using this. Okay, and that is my context-free grammar for denoting this simple case. Okay, so that is the idea. I can express all these facts about language, how words are grouped together, which groups come together by using these prediction rules. So now once we know that, what is the formalism of context-free grammar? Very briefly saying. So in context-free grammar, when we study, we mainly talk about a quadruple. Okay, so there are four important set of variables. So firstly, I have set of terminals. They are the leaf nodes in my tree whenever we see. So they will always come at the end, and whenever I get a terminal, I cannot derive anything from there. So I have a set of terminals. So we will see what, in the case of language, what do they mean. Then we have a set of non-terminals that help me do the derivations. Okay? So these are all the variables from which you can further derive more strings. Now, so what is different in the case of NLP? What is some distinction we will make? So in the set of non-terminals, we will also distinguish a set P that are pre-terminals. Okay? So pre-terminals are those non-terminals that will always derive terminals. So they will always give me leaf nodes. Okay? And with example, it will be clear what are they in the case of language. Then I have a start symbol from which I am starting my derivation. Okay? So if I have to model a sentence, I should be starting with S, that is the sentence. And then I have the rules, and they are always of the form X going to gamma. Okay? And X has to be a non-terminal, a single non-terminal, and gamma can be any sequence of terminals and non-terminals. And that is the constraint that we see in the case of context-free grammar. Okay? So this is the quadruple, and we are also seeing a pre-terminal, that is a subset of non-terminals. Now in the language, what are terminals and pre-terminals? Terminals in the language will mainly be the final words that I see in the lexicon, and pre-terminals will be part of speech categories. Because from the pre-terminals you can derive only terminals. Okay? So let's see one example, and then we can point out what are terminals, pre-terminals, and non-terminals. So this is what we were modeling earlier. Okay? What is a noun phrase? Determiner followed by a nominal or a proper noun, and where nominal is a noun or a set of nouns, which I modeled using noun followed by a nominal. Now, are you seeing some terminals here? So there are no words, so there is no terminal. So I cannot use that to derive a phrase or sentence. It can only give me a set of grammatical categories. So I have to include some facts from the lexicon to make it a complete grammar. Okay? So for example, I can include some determiners, some nouns and some proper nouns. So here I am including a and the as two determiners and flight as a noun. Now here, can you identify what are the terminals, non-terminals, and pre-terminals? So terminals are the words in my lexicon. So a, the, and flight are my terminals. Pre-terminals are the grammatical categories or pause categories that will always give me terminals. Can you see that? Determiner and noun are only giving me terminals. So these are my pre-terminals. And apart from that, all the variables like NP, nominal, they are my non-terminals. So proper noun, there is no example is given, but proper noun is also a pre-terminal. Okay, it's a part of speech category. It can give you some words in the lexicon. So these are my terminals, non-terminals, and pre-terminals. So now, once you have this CFG, you can use that to generate various phrases or sentences in language. So for example, here this is a CFG for noun phrases. So can I generate a flight, the phrase a flight using this context-free grammar? Okay, so I will have to start with NP and I have to generate a flight. So what is the first derivation I will do? From NP, I will take this rule, determiner followed by a nominal. Yes. Now determiner will give me a. Now from nominal, I cannot go to flight directly. So from nominal, I will have to first get a noun, and from noun I will get the word flight. So NP gives me determiner nominal, nominal gives me noun, determiner gives me a noun, and a flight. That's how you generate a sequence of words using this grammar. And now you can do it for any sentence. You can define a grammar for a sentence and generate sentences from that. So okay, so what we are seeing here, so you can use a context-free grammar to generate a series of strings. Okay, and the sequence of rule expansions, so the sequence that you are using, starting from NP going to determiner, nominal, then determiner noun, then a noun and a flight. This is called the derivation of the string using this grammar, and we use a tree structure to represent this derivation. Okay? Remember one of the very first trees that we had shown as a motivation. So, we will try to come up with such trees using these derivations, and they will be called the parse trees. Okay. Now, what is the notion of grammaticality using context free grammars? The idea is that you have defined one grammar for your language, okay, and you have to assume that this is the only grammar. So, any rule that is not expressed in the grammar is not allowed in the language. So, now when you are given a new sentence, if you can see that there is a way to generate this sentence using my grammar, this sentence is grammatical as per my grammar. If this sentence cannot be generated using the grammar, this is not grammatical. This is a simple notion. Or using this grammar, whatever sentence I can generate is grammatical, whatever I cannot is non-grammatical. So, that depends on the grammar that you have designed, the context free grammar that you have designed. So, yes, so whatever can be derived are grammatical and others are ungrammatical. Now, CFGs are interesting because they can also model some very interesting phenomena in language syntax, like recursion. Okay? So, in language you make lot of big sentences by doing recursion. So, for example, a prepositional phrase can be written as a preposition followed by a noun phrase. Okay? And a noun phrase can be written as a noun phrase followed by a preposition noun phrase. So, you see there is a recursion here. Yes? So, I can encode a noun and a noun phrase, noun and a prepositional phrase here. Prepositional phrase can again encode a noun phrase, which can encode a prepositional phrase. So, this is a recursion that is very common in language. Okay? So, let us see one example. So, this example is the mailman at his, and this is the complete noun phrase starting from lunch to the end of the sentence. Lunch and noun phrase is a noun followed by a prepositional phrase with, and this is not shown here, but this again starts a noun phrase. Prepositional phrase is a preposition followed by a noun phrase with his friend from the cleaning staff and all. This is a noun phrase. And what is this noun phrase? Noun, okay, his friend followed by a prepositional phrase, and so on. So, this recursion is very nicely captured by using context free grammar. Okay. Now, so I will end this lecture by just saying what does the context denotes in context free grammar. What is the meaning of context? Okay. So, in language we talk about context as such. Okay. So, we say context is given a word, find out what is the context, what are the previous words and what is the topic and all that. So, these are all define the context. But this context has nothing to do with what is context in the case of context free grammar. This is a very formal notion. Okay. So, so this has nothing to do with the ordinary meaning of word context in language. So, all this means is that in context free grammar, whenever I am doing a derivation, okay, so whenever I am writing A gives me BC, okay, or say noun phrase gives me determinant nominal, whenever I am writing a rule like that, it means is that the non-terminal on the left is all on its own by itself. Okay? It does not need any context around it. So, I can always write A goes to BC irrespective of whatever is around my word A. Okay? So, even if I have x A earlier, I can use A to derive x BC, and if I have irrespective of what is x or any y, I can always write this, and this x and y are immaterial, they do not matter. It can be null, it can be whatever. Similarly, if I am inferring, whenever I see a BC, I can always infer a. So, this it might have come from A, independent of the context of BC, and this is what is context free grammar. So, if you would go to the next level of context sensitive grammars, there you need the context. This word A can derive BC in this particular left context, in a particular right context. We do not need this left and right context in the case of context free grammars. Okay. So, this is what the context, the word context means in this case. So, So whenever I have a rule A goes to BC, it means that I can write A, I can always derive from A, B followed by C, regardless of the context in which A is found, or whenever I find a B followed by a C, I can infer an A, regardless of the context in which B and C is found. So this is CFG for us. I have not gone to a lot of basics of context free grammars, and I suggest that you can quickly look at any of the chapters in the basic books of formal languages and automata theory. So, but whatever is required for our task of doing parsing, I have covered in this lecture, and I will cover the necessary things in the next lecture. So, in the next lecture, what we will do, we will start from CFGs and we will see how we can use that for actually doing the parsing for a given sentence in the language. Okay, so we will take up various approaches for parsing. So that will be the next topic for the next lecture.